There is only one thing that separates good developers from great developers. Great developers never stop learning. Be it design patterns, new frameworks, or new programming languages, as long as you're expanding your knowledge base and getting exposed to different ideas and concepts, your overall understanding of the software development field will deepen. So, for the past couple of months, I started to learn Python, and I believe it is one of the best decisions I made in a long time. In the next couple of minutes, I'm going to tell you why. For a bit of context, I am a developer with more than 10 years of experience. I started as a Java developer and explored various other programming languages until I finally switched to Kotlin. These days, I spend most of my time in the JavaScript world. During the years, I had a few revelations regarding programming, most of these caused by me switching between tech stacks. I have a video on this exact topic, so check out the link in the top right corner if you want to find out more about my dev journey. Here is the thing. If you spend all your time working with the same programming language and framework, you are missing out. For instance, I was a strong believer in object-oriented programming and in following all the design patterns under the sun in my Java development days. Functional programming was of no interest to me, and everything outside the Java ecosystem seemed like a joke. Fast forward a few years, and while I still see the value in the rigorous approach enforced by Java, I also appreciate the simplicity and the flexibility behind a programming language like TypeScript or an ecosystem like one Deno is offering. So, the first question I should be answering is, why Python? Well, here are some good reasons. First of all, based on a lot of metrics, Python is the second most popular language in the world. Not only that, but in 2022, it saw a 20% increase in usage. We'll discuss in a second why this happened. While following trends is not always a good idea in the dev world, I believe Python's second place is a well-deserved one. Also, this high usage usually ensures an engaged, vibrant dev community and a lot of prospects in the job market. The second reason to use Python is its versatility. It is a multi-purpose language which supports both object-oriented and functional programming. It is often described as a batteries-included language due to its comprehensive standard library. You can use it to solve both small tasks and build large-scale applications. On top of that, I think it's fair to say it is pretty much the de facto solution for anything data science or machine learning related. Finally, Python enjoys a rich variety of third-party libraries and tools. I am mostly involved in web development these days, so I'll just mention the likes of Django and FastAPI, but you will find libraries and tools for any use case under the sun, ranging from data science to embedded development inside Raspberry Pi to building graphical user interfaces and even game development. I should also mention that this video is not going to be an overview of the basics of Python development. I'm not going to review its syntax, the control flow, or tell you that it uses whitespace indentation instead of curly braces to define code blocks. After a while, you realize that things such as these ones are the easiest to master. However, I find it interesting to take a quick look at the philosophy behind Python. This is nicely summarized in the Zen of Python, which includes ideas such as beautiful is better than ugly, explicit is better than implicit, simple is better than complex, and readability counts. As a developer, what really matters is that you understand broader concepts and ideas and the reasoning behind them. Maybe one of the funniest situations I've seen to support this idea is George Hutt's live stream, where he was figuring out the basics of Scala while working on improving the Twitter search. If you didn't know about this, when Elon Musk bought Twitter, he decided he wanted the Twitter search fixed and hired George to do it. George is, among others, an extremely talented coder with a very impressive resume. He is known for live streaming long coding sessions, and in one of these streams, he jumped into the Twitter codebase and started playing around for a bit. Funnily enough, even though he is an extremely accomplished programmer and constantly works on some of the most complex software issues, a big chunk of the stream is him trying to figure out basic Scala stuff, such as reading from a file or various compilation errors. So, to iterate, the real value of a good developer is his understanding of a wide variety of programming topics. The basics can be learned in a couple of hours. Being able to jump in and solve issues in any type of project, regardless of the complexity or the tech stack, is the real deal, and this is what you should aim for. So, let's discuss some of the core concepts behind Python and the impact these are having in the development process. As a quick FYI, most of this video is based on the knowledge I gained by reading the Quick Python book. One important aspect of the language is its dynamic typing. In short, what this means is that variables are not tightly coupled to the referenced object and they act more like a label. As a result, types are associated with the object, not with the variable. you'll have the flexibility to assign different objects with different types to the same variable, but you'll lose the convenience of type validation. I will let you guys decide if this is a good thing or not. Looking back at the JavaScript ecosystem though, people were fairly eager to adopt TypeScript just to get some extra precaution measures and a better dev experience. Despite it being dynamically typed, Python is also strongly typed. So, while the type safety is verified at runtime, you still can't do weird stuff like adding numbers to strings. In contrast, a language such as JavaScript is weakly typed, and you are probably familiar with all the weird little things JavaScript does when working with types. Next, let's discuss another core topic, interpreted versus compiled languages. So, you'll read everywhere that Python is an interpreted language. However, it's important for you to know that most modern languages still rely on a compilation step despite them being interpreted. Of course, this might not be obvious if you compare Python with a language like Java, where compilation is an independent, obvious step which converts your .java files into .class files. However, for performance reasons, when you are running a Python program, the interpreter first compiles your code into bytecode and then runs the code line by line. Another interesting aspect of Python is its global interpreter lock, or in short, GIL. This is a mechanism that allows only one thread to hold the control of the interpreter. Getting deeper into this topic is a very interesting endeavor and proves one of the ideas I mentioned earlier. Programming languages choose different implementation solutions, which, in turn, lead to various benefits but also to some drawbacks. So, while programming languages such as Java spend a lot of time and effort to offer its users powerful tools for multi-thread work, Python decided to get rid of concurrency and associated issues like race conditions or deadlocks for better memory management through reference counting. This decision might seem questionable now, but experts consider the global lock one of the main reasons Python is so popular today. The GIL is simple to implement and was easily added in Python. It provides a performance increase to single-threaded programs as only one lock needs to be managed. Of course, a 10-minute Python video doesn't do it justice, and once you dive deep into the language, you'll find it comes with a lot of features and libraries to support programming paradigms such as aspect-oriented or metaprogramming. Before taking a look at various web solutions for Python, please consider liking this video and subscribing to the channel. During this video, you've seen me building some REST endpoints with the help of FastAPI. Python is used to build some of the most popular web apps out there, and it powers even the likes of YouTube and Instagram. When it comes to web development, you'll find a wide variety of frameworks, ranging from fully fledged solutions like Django, which handles everything from database integration to authentication, to micro frameworks like Flask. Considering the current trends in web development, the chances are you will use a JavaScript meta framework for all your UI work. This leaves the backend REST API in the hands of a tool such as Node, Deno, or in this case, FastAPI. FastAPI does a great job building on top of the power and the flexibility of modern Python, while also leveraging open standards such as OpenAPI. All these lead to a great solution with all the features you'll need in a real project. Let me know in the comments if you want to see more Python-related videos moving forward, and until next time, thank you for watching.